Morning everyone, it's Mr. Sutton here, and I'm just going to go over the task that we're going to be doing today. I've also got a few other bits and pieces to talk about what we're going to be doing over the next couple of weeks, a sort of plan, some extension activities. But before I go on to any of those, I'd like to discuss what happened yesterday. And I'm in Microsoft Teams just here, and obviously I'm recording this on the Thursday morning. Yesterday we had the live lesson, and I have to say that I was a bit disappointed with how it actually worked out. We can see here that on the live lesson it says engineering live lesson, and it's a recording of it. One of the things you need to understand is that I will always record the lessons, as indeed all the other teachers will. And what I found particularly disappointing was the activity at the end. I envisaged that when we did the live lesson, it would be like a live lesson, that you would have your microphones on and be able to ask questions and potentially also reply. Now, I know that I don't think it's ever been particularly made clear to all the teachers exactly what and how these should be done, and I don't think it's been made very clear to you. But if I'm going to do another live lesson, I'd like you to have your microphones on, or at least be able to ask questions, or else, if I'm honest with you, there's no reason for me to actually do live lessons. And what I'm going to do moving forward is, I'm going to see what you think about this one. I am going to do pre-recorded lessons for content such as this with activities so that I can get you to do something, and I am then going to do some drop-in sessions where you will be able to do those. I'm going to discuss those at the end of this video. However, one of the things I don't want to find is that everybody has all their microphones muted while you are in the lesson with me, and as soon as I leave that meeting, then we get people talking. From now on, if I do a live lesson, I'll expect everybody to leave the lesson before I do. And I also expect a bit of, respect, really, for what we actually do, because we're in a situation where that is the only way we can move forward with this. I will say I've had one person apologise for the behaviour yesterday, and I thank that person and their maturity in doing that. I'm just disappointed with the other people that sort of involved as well. I'm leaving it there. I'm not going to go over it again. I just don't want it to happen again in the future. Now, for everybody else, we are going to be having a look at forging today. Forging and casting in particular. Now, there are going to be a couple of videos that I'm going to use for this. You can get a bit more information on this one, but this is a small little section of the theory side of things. And if you remember, I said that we would be finishing up most of the theory over the next week. By the end of next week, we are pretty much done as far as theory is concerned. We've got a little bit that we want to recap, and I'm going to specifically look at the maths side of things because there is a maths question, but I'll talk about that later. We're going to be looking at forging and also casting today. Forging is where you take metal, you heat it up, and you shape it in a way using usually a larger, heavier weight. You can see here we've got very much your kind of blacksmithing style of thing. This is where steel, and it can be any grade of steel, so it can be anything from sort of iron, solid iron, all the way up, mild steel, tool steel, you name it, it can be treated in this way. You heat it up repeatedly, and then what you are doing is, just like a blacksmith, I'm sure you've seen it before, is you beat it with a hammer. When the actual metal is in this malleable state, when it's heated up to this sort of level, it's quite malleable. It can be shaped, it can be rotated, twisted, you name it, and we can see here some quite nice little ideas with this sort of banister rail or things like that. And that allows it to be bent into particular shapes using tools. Very, very old technique. The only thing that you need to understand is that you have to heat it up, and this anneals the metal. It actually anneals it, it softens it, it gets it ready again. By then heating it repeatedly, what happens is that the crystalline structure actually inside the metal changes. So it starts to change on the inside of the metal, and it becomes harder. It becomes what we call work hardened. Now, this can be particularly useful. Say, for example, you are going to be doing something like this. This is where that particular person is making an axe blade. You can see here, this is where the handle would normally go in. This part round here is made from a more malleable metal, which can be easily forged and shaped. And then if you look at this end, we have a harder piece of tool steel. So this is where you've got that harder piece where you've got that slightly higher level or slightly higher percentage of carbon coming into the metal, which means that it can keep a blade far better. And this is heated repeatedly. It is obviously hammered into the shape, and then it can also be ground down once it's fused together, because forging can at the same time forge the metal into one piece, and then it produces that axe blade. So you can see here that this bit just here, the bit that actually holds the sharp edge, is usually made out of a higher carbon steel. So it's joining those bits and pieces together and forming an axe from those, and that is one of the basic ways in which we think of shaping metal. I've got a video and I've included this one in here. We've got this one just here, and let me just sort of mute the thing again, which shows it in an industrial process. Now, an industrial process using forging does pretty much the same thing. It is using metal that are heated up to a particular temperature, and then they are shaped. Now, this particular one is actually used where they're actually rolling the steel or even squishing it into particular parts. So if we look at that, where you've got the rolling up this one, but that is where it's placed into a forge, and the mould beneath is used where it's hammered into that mould. So these, for example, the molten or partly superheated metal can be placed into a mould and squished into shape. Really, the main thing you need to understand is that it is really when you're actually heating metal up and then repeatedly hitting it with a hammer, that's what we call forging. Now, that can be done either by hand, like this gentleman is doing just here, and he's actually using something to indent into the metal there, but you're using a lot of weight onto the base there, and that helps us to form the individual shapes. So you can see here it's forming the shape up like so, and the metal starts to cool down. It doesn't cool down that quickly because that is very, very hot, that piece of metal is. So forging is really using repeated blows, reheating it again and again where necessary to try to actually form those bits and pieces together. And that is forging in a nutshell. So very straightforward and simple. Those videos, by the way, on how to do hammer forging. This guy here is doing cold forging. I will place this one in. He uses it, and you can see there's a mould just here. It's actually for making a dome of all things, and it's clamped in, and he's using this hammer action, and that can also be used to hammer out softer materials. Things like aluminium allow you to do this, and that allows you to make a dome, because what you do is you're stretching the metal by hammering it repeatedly, and that can actually form the dome. Second process we're going to have a look at is casting. Now, the one that you need to really know about, there's many different types of casting, but sand casting is the main process that I would like you to have a look at. Now, I've got a couple of those in the playlist which I will link to. There's a couple of things about sand casting. This one is quite a nice one because it just very, very easily takes you through this animation of sand casting itself. First of all, and let me just pause that slightly before there, what you create is what we call a wooden pattern. Now, a wooden pattern is literally as it looks there. It's made out of wood usually. Sometimes it can be made out of other materials, but it is the part itself. So this is the two halves of the part. There's these bits here and here. Those are going to be where the actual molten metal flows in. You'll see what I mean and how it's done in a minute, but those are where you obviously have to have somewhere where the metal can flow in, and potentially you always have to have two so that the air can escape from another place. And the placement of this is very important so that air can escape, because if air becomes locked inside the mould, you'll get a bubble of superheated air or gas, which means that the metal won't flow into that particular point, or it won't be as nicer casting as it could be. Moving on, we have, and it's refusing to actually do it, we have these that are placed around it, and then the sand is poured into the box, sieved into it, and it is compressed. So you tap down the side. Now what that means is that the sand forces its way all the way around those patterns, those wooden patterns, and it actually becomes quite solid. The fineness of the sand is not really the type of sand that you would have on a beach. It's far finer than that, which means that all the grains come together really quite compact, and it means that it picks up all of the details that you could possibly have. It's then turned over and the patterns are removed. So you can see that those wooden patterns are just taken out, they're drawn out very, very carefully. And what you get is you get that space, the negative space where the patterns used to be, formed into the sand. They're then placed one on top of the other. So you've got the two halves coming back together, and then you have these holes, which I spoke about earlier, which are where the metal is actually poured into. It's bolted together, and molten metal is poured in. And this can be aluminium, could be gold, it could be, steel, any of these, and it cools down and solidifies. You then take the top off, and normally what they will do, it's not as easy as that. They usually have to clear away the sand by sort of knocking it off, and it's often reused again and again and again. Some areas of the sand may have become damaged. You have the finished part. Now the thing with sand casting, is it does produce quite a rough surface texture. So it's used for, bits and pieces like engine blocks and stuff like that, which then can be cleaned up afterwards and the surface is machined. But it is a very quick, cheap and effective way of casting metal. So that's sand casting. Very, very simple technique. You don't need any more than a decent couple of diagrams than that, and also forging in the usual type of way, and we can upload that. So if you can upload those ones so I can have a look at that, and I will obviously mark those again, and I'll be looking for those to be done by Wednesday of next week. Now what I'm also going to talk about, as I promised at the beginning, is some extension activities, because I know a number of people have asked for sort of extra bits that they could do, which will allow them to extend their capabilities. So what I decided to do, rather than giving specific ones every single lesson, I've decided to come up with this extension activities list, and I'll upload this along with the assignment as well. These are all things that I'd like you to choose from. So if you are going to do an extension activity, it's one of these 5 things which is going to really help build up your skills and get you prepared for the next stage. One of them is have a go at third angle orthographic projection. Any item you wish, as complex or as simple as you wish, you can do that. You can then send that to me and I will give you some feedback on it. So the best way of doing that is to actually put it into a chat thing. What I'm going to do is I'm going to set up specifically every single week, and it may well be on Wednesday next week, I'm going to have a live session or drop-in session for you to just come in and say, oh, what do you think to this? And we can have a discussion about what you've done. Or you may be able to have some questions about the course generally, or something you don't understand. So I'm going to do that as kind of a drop-in seminar session. You can also do a bit of creating freehand in preparation for design development in Unit 1, because we will be moving on to that. So you're going to have to do some sketches. So that's really important. To help you with that, Mr. Newbold has created, now this was for Year 7. So bear this one in mind. He's done a video of how to do oblique drawing. Now some of you, all of you have had a go at oblique drawing. You obviously know Mr. Newbold as well. He's taught you. I've linked there for that YouTube video. It is really useful. I would definitely have a go at looking at that one if you're a bit of a loose end, or if you need to build up on your 3D sketching abilities. That's a really nice one to have a look at. And then finally, we've got 2 of these, which is specifically aimed at using the Access FM. We should all know what the Access FM system is. I will put the Access FM chart in our files inside the Microsoft Teams folder, so you will be able to get those bits and pieces if you need it. And that is really, you can have a look around your home and do an Access FM analysis, product analysis of a product. If you do something that is real life, that is more of a disassembly. If you do one which is more just taking one from the internet, then that's more sort of product analysis. I would prefer it if it's something which you do first hand. It shows a lot higher depth of knowledge. And remember, we need some decent thinking and justification for your points raised on that. And in the same way, Specifications. We're going to need to really look at specifications. What you can do is almost reverse engineer, which is what we discussed previously. And that is where you take a product and you decide on what the original specification was. So, for example, you may well have for a laptop, you're going to need to say, well, aesthetically, it has to look like a business product so that it looks as though it is something you would take into a meeting if it's going to be a business laptop. Ergonomics, making sure that the keys are set in a very specific way so they're the right size, shape, layout, so people can use them for extended lengths of time. That type of stuff. These I'm more than happy to assess at just about any time, so you can send those through to me. But if you want specifically me to give you verbal feedback on your work in a meeting, then I'm going to set that one up with you. What I will do is I think I'm going to have that on most Wednesdays at approximately 10:30. So I will share that in the post as well. This is the lesson plans that I've got over the next couple of weeks. Obviously, you've got the forging, casting and shaping of metals, which this is the video for. And on Monday, we're going to look at plastic moulding, injection, rotational blow moulding and vacuum forming. The 17th, Wednesday next week, is third angle orthographic practice, which I will give you all a little bit of a video and some advice on that one. And that's one of the first ones when I will also do a drop-in session. So that will be a drop-in session where you can pop in and just say, look, I've done this drawing, what do you think? And I can give you feedback straight away on that one. Friday is going to be health and safety in the workshop. That's all about the science in the workshop, plus also a knowledge test. I'm going to start bringing these knowledge tests in like a quiz format, which will be auto-marked, probably multiple choice, but I need to start testing your retention of knowledge from all the bits and pieces we've been doing. The following week starting the 22nd of June, I am going to be focusing on maths in engineering. That's all the bits that we've done so far, areas, volumes, you name it, different types of electrical resistance and amperage, wattage, all those ones, Ohm's law. I'm going to be looking at that for the whole week. And on that Friday, I will be doing a quiz as well, just to sort of follow up on that one and check that we've got that knowledge retained. Monday the 29th will be Gantt charts in readiness for Unit 2. Don't worry, you're not supposed to know what that is, but you will hopefully know by the end of Monday the 29th. That brings us on to the 1st of July. Who would have thought it? And that will be a knowledge test on that one. Again, I will be doing another session. So on that Wednesday and the previous Wednesday and the Wednesday before at 10:30, it is going to be a drop-in session for people to just pop in. If they need to, I'll be available for a good half an hour online and you can just drop into the meeting. And Friday, the 3rd of July, is going to be feedback. So I will be giving you a feedback video on what you have done so far. Those are all the bits and pieces. So Wednesdays are going to be the new drop-in live sessions, and we will just leave that as open. I will give you more information on that on Monday. I'm going to discuss those with other people in the department and let you know about it. Hope that's all nice and straightforward and simple, and I look forward to seeing how you do with those. Good luck, have a nice weekend, and I will speak to you all soon. Take care.